Hi, hello. So today we are going to start another course that will be about graph. We will cover this graph into a step-by-step way so that you can crack any coding interview after that. So first we will talk about its simple topics, that what is graph, and like I have mentioned here, all these terms, we will talk about them. Later we will see that how the disjoint set will work. Then after disjoint, we will look for what is DFS, and then we will see what is BFS, and then we will talk about how to construct, like what algorithm will be used to construct minimum spanning tree, and then we will see, like here you will see Kruskal algorithm, or you will see Prim's algorithm. So we'll talk about single source shortest path algorithm, and then we will see simple Can's algorithm, and we will look for topological sort and all these things. So let's jump into these terms. Very simple. So what is graph? What data structure is this? So normally we use it in normal day-to-day life. Let's suppose if we are talking about a person, he has a relation with it. Let's suppose he is friend of this. In that case, we were saying that this person has a relation of friendship with that other person. It is A, that is B. And suppose this one has another friend, which is friend of B, its name is C, suppose. So we are talking about the graph actually here. So let's suppose B can have another friend, which is D. So in that case, we are talking about some graph. Also, when we were talking about some chemical relation, so there are two H hydrogen atom and one oxygen, then you're also making a graph there. When we are talking about the distance between two cities, let's suppose this is city A, and there is a path which goes to city B. So it is also making a graph. So that city B can go to, let's suppose, some city A, C further, and all that is making some graph. So what is graph? It means that we were actually trying to find the relation between entities. So there are some entities. That entities could be person, these could be cities, some element, that could be any entity that we can talk about. So there it shows a relation between them when they're different entities and they are being displayed like that, and then we draw some line in between of that which shows actually the relation between that. Now we talk about what is the type of graph. There are three types of graph actually. Undirected graph. Undirected graph mean that when, let's suppose, there is a person A and there is a person B, they both are friend. Once A is a friend of B, then B is also a friend of A. In that case, we show that relation with a straight line without making some arrow. It is bidirectional. So in that case, we talk about this as undirected graph. And any types of graph which is directed graph, in that case, let's suppose if you were saying that this is a city A and there is only one road which goes to city B, like that, you can't go from B to A, you can just go straight from A to B. In that case, it is a unidirectional. Or in some other way, you can think about some social network when, let's suppose, this person A follows, like he subscribed to a person B, so let's suppose it is going to subscribe. In that case, we are showing that A is subscribing person B, but doesn't mean that B is also going to subscribe A. So that will be called as a directed graph. Weighted graph could be, let's suppose this is city A, that row goes to city B, and that could be directional or that could be undirectional. Directional or undirected graph, that could be, but you have to mention some weight here. Like that weight could be any parameter, like it could be a distance, that could be, let's suppose, cost of petrol, or that could be anything I like which shows the weightage of that relation. So those type of graph, we call them weighted graph. That could be directed or that could be undirected. So we come to know that there are three types of graph: undirected graph, directed graph, and weighted graph. All right, so these two topics are done. So this is good, this is good. Now we talk about what is vertex. When we were talking about all these things, let's suppose this is a person A who subscribed person B, then that person is being displayed like a vertex. So this one is called a vertex, that could be called a node. So we call them vertex or we call them node. And yeah, this is how we display actually like that. So they normally in mathematically we were just displaying them like U and this is V. So this is how we reflect them. You can give any name to them. So what is edge? Edge is actually that line. It could be directed, it could be undirected. So those lines which shows the relation between these two vertices is simply called the edge. All right, go for the next. So these two are done. Now we talk about what is path. Path is actually shows that, let's suppose if there is here is a city A, you go to city B, then city C, there is city D, like that. So there is a path goes like this or that. Now there is a path from A to D. You can go from, let's suppose, A to D by A, then you can go to B, and then you go to D. This is called the path. That it shows that what are the places, nodes where you have to go, and then you can go from your source to your destination. That's the first path. Second path that you can go, like you can say A, B, C, and D. You can go this way, like you start from A, then you go to B, then go to C, and then go back to D. So these are called the path. All right, so this is done, and that's done. Now we talk about what is path length. So path length means that all number of edges, like to go from source to your destination, that path, how many number of edges are there. So in this path, like A, B, D, we have path length equal to 2, because there we are just going from this edge and that edge. So that path length is equal to 2. And for the other reason, other path here, this is the 1, 2, and 3. So this will show the path length equal to 3. So normally number of nodes minus 1 reflect your path. All right, what is cycle? Cycle is pretty simple, that when, let's suppose, you start from source A, you go to source B, then you go to source C, and then you get back. So you go from the source and then you get, and your target ends also to your source. So when they both are equal, in that case we get a cycle. Like here in these example, which is an undirected graph, there you can see from A to B, B to D, and D to A back. So here we will get a cycle. Now in this path you can also see this is also directed graph, but it doesn't have a cycle because A to B, B to D, or you can get A to D, or A to B and C. There is no cycle. No one is coming. It's directed graph, but no cycle is there. Okay. All right. So what is negative weight cycle? Negative weight cycle mean that, let's suppose if we talk about this one, suppose it is -6. In that case, when we were looking at this cycle, like A to B and then D and get back to A. So this cycle is when we sum that, all the weight of that. So the weight we will sum, that will -2 plus 2 plus 1, it will result -3. When the sum of the weight of a cycle result a negative value, we call it negative weight cycle. That's it. We go for the next one, where we talk about what is connected nodes. Connected nodes mean, let's suppose, when A is connected with B and B is connected with C. So A and B are neighbors. They are connected nodes. They're directly connected. And A and C are also connected, but they were indirectly connected. Like you have to go from A to C, then you have to go from A to B, and B to C. So they are indirectly connected. So these are called connected nodes. And if I will just draw D here, which is an unconnected node. So in that case, A, B, C are connected, but D is not connected. So that's also a difference between a tree and graph, where in trees, every node should be connected. And in graph, there could be some node which is not connected with the other. So that's what we call, when everyone is connected, we say all those nodes are connected nodes. Okay, so what is degree of vertex? So degree of vertex mean that how many edges are coming to some node. Let's suppose if we talk here in this example. So in this example, you can see what is the degree of B. The degree of B is 3. And you can see that one edge is coming inside, 2 edges going or outside. So the degree is 3 because it just shows degree of vertex is how many edges are connected with this particle vertex. So this is, we call the degree of vertex. And what is in degree? In degree, very simple, that how many edges are coming in. So if we can see here, there is only one edge which is coming in to that node. We call it, that's in degree. So it is 1. So in degree is 1 in this case for that node B. And what is out degree? That also explained very easily, that how many edges which are going out of this vertex are called out degree. So there are 2 edges which is going out from this vertex, and we called it out degree. All right, I think that we have covered all those points, and there is nothing more that we can talk about. Further, in the next video, we will talk about that, what is disjoint set, and for sure we will see that what comes in the next one. So I will go with every video one by one, and I will complete that whole course about graph. We will do some lead code questions inside, and we will see that we will stand. And hopefully I will try to complete within 1 or 2 months. Let's see. Thanks.